Okay, so this is the detailed data that I got from 5 different subjects, measuring their reaction time using the RT time script that I made. The first subject, Emma, here's her data. All of her reaction time is measured in milliseconds. By using the first script, which is D equals 0 millimeter, I got her reaction time right here, the first column, and her average reaction time is 208.5 milliseconds. The standard deviation is 55.85. That's actually not very small, which means the data in this column vary a lot. It's not really consistent, and the accuracy of the first column, the relative accuracy is 73.2%. It's not exactly high. So I use the second strip, which is D equal 5 millimeter. In this case, I let it fall for 5 millimeter before I let her see the reaction strip and react to catch it. So this is the data that I got from her from using the D equal 5 millimeter. The first time that I tried reading her reaction time, it's actually she actually react really slow. So this first try could be a mistake, but starting from the second time is actually gotten more consistent, and but it's not actually very consistent down here, because the data is still very a lot. So the average reaction time of this strip is 202.8 milliseconds, and her standard deviation is 49.4. It's actually still high, but what we got here is the relative accuracy is 75.6, which is actually increased. I mean, it's improved compared to the last time using the D equals 0 millimeter. And then to improve the data more, I use D equal 10 millimeter and D equal 20 millimeter. So these two are the average reaction time that I got, and from the look of it, it seems that her reaction times, I mean the average reaction times actually decrease as I use the D 10 millimeter, and it actually gets smaller when I use the D equal 20 millimeter. So this number is actually more precise than this number, and this number is more precise than this one and this one. And so we can see that the deviation is 28.5 and 28.9, which means not as varied as the last two times, and the relative accuracy is actually increased also from the 70s to 85 and 82.75. So with this reaction time, she's not exactly fast compared to the next subject, which is this girl. by her first column is gotten by using the D equals 0 millimeter reaction strip, and her average reaction time for the first column is 190.9 milliseconds. The standard deviation is 34.14, which is actually really small compared to Emma in her first column, which got the standard deviation of 55.85. And also the accuracy in this column is actually much better than the one of Emma. So the average reaction time for this subject is also decreased as it go up from D equal 5 millimeter and D equal 10 millimeter, but we have a really weird case here where the reaction time is actually not decreasing but is increasing. This is maybe just a mistake from me, the experimenter, or maybe she's got slower after so many tries. But her standard deviation is really small compared to the subject before, and so this is really good. And the relative accuracy is actually increasing also as I change to the third strip, the 10 millimeter, and the fourth strip, the 20 millimeter. So go down to the third and the fourth subject. They also have a case where their reaction times actually decrease. I mean, they react faster as I change to the better reaction time strip, and the relative accuracy actually get better as I use these two, the D equal 10 and D equal 20, rather than using the 0 one or the 5 millimeter one. Beside from the first subject, the other subjects actually have the much smaller standard deviation, which around 15 from 15 to 20 is actually pretty good. For this girl, her relative accuracy is actually pretty high compared to the other three. The relative accuracy for the first column, which is 0 millimeter, actually 90.317%. That's extremely high, but the fact that as I change to the other two, the D equal 10 and the D equal 20 millimeter strips, the relative accuracy get better. And this is the last subject, which is myself. I also, my reaction times is actually not really fast here, but the standard deviation is not really large, and the relative accuracy also increasing as I change to D equal 10 millimeter strips and D equal 20 millimeter strips. So what I can conclude here is that as we let the reaction time strip fall for a longer distance before the subject see and react to it and catch it, the relative accuracies actually increase. And this actually, the reaction time of the subjects um, also have something to do with the relative accuracy. Especially in the first column, for those who have a really slow reaction time, it's actually not that matter to not that matter to the accuracy. But for those who have a small reaction time, like especially from 150 built to and faster, it's actually really affect the relative accuracy of the experiment, as we use the d equals 0 millimeter from 150 to and faster. The time gets closer and it's not that accurate compared to when using d equal 10 millimeter and d equal 20 millimeter.